Right, this video is 2019 Level 1 Science exam, it's mechanics, and I'll be working through question 2. Right, question 2. An adult and a child's feet sink into soft sand. The footprints are the same depth. The child's footprints cover a smaller area than the adult's. Pressure is defined as force exerted divided by the surface area contact. If you go into your formula sheet, it's this one here. So it's pressure equals force over area. So we'll just chuck that formula in. Pressure equals force divided by the area. Using this pressure definition, explain how it applies to the adult standing in the sand. So I'll just pause, write it in, and then discuss. Right, so I've said the adult has a weight force acting on it. So literally, you just need to do it step by step. This is the first thing you need to address, the force. So the adult has a weight force acting on them. You've got to use weight force. You could use gravitational force as long as you say gravitational force, not just gravity. And then I say this weight force is distributed, because that's what it is. It's distributed over the surface area. Oops, I missed that word. Area of the feet, creating pressure. I'll put divided because that's what it means. Divided by the surface area of the contact. So you go force, contact area, and then you need to describe like how this works with regard to pressure. So creating pressure. Right. Next question. Surface area of one of the adult's footprints is 0.02 meters squared. We'll just cross that out because we never use centimeters ever. And the surface area of one of the child's footprints, don't use centimeters, is 0.015 meters squared. The adult has a weight of 690 newtons. Show that the pressure the adult exerts on the sand is 17,250 pascals. So pressure is equal to force divided by area, which is equal to, what's the force of the adult? The weight force is 690 newtons. You don't have to put the units in, but I'm just doing it anyway. Divided by, what is the adult's footprint? 0.02. I'm not going to leave the other ones in because these are just, they don't count for anything. And that equals, so I just realized when you do this with the 0.02, that's 1 foot. You need to use 2 feet. So that's like a common misconception that kids can make. I've highlighted 1, and I've got 1 foot is 0.02, 2 feet is 0.04 meters squared. So it's total force divided by total area gives you 17,250. Right, next question. Explain how the footprints are the same depth, although the mass of the child is smaller. Include in your answer discussion of pressure, surface area, and mass. Right. So I'll go through it. Pressure is equal to force over area. The adult has more force, but he has more area, so he has the same pressure, so he sinks down the same amount as a child, because a child has less force, but also less area, so that's how their pressures are the same, and that's why they sink down the same amount. But I'll pause it and then just write it fully. So I've said the adult has more mass than the child, so has a greater weight force. However, the adult has a greater area, so as pressure equals force over area, the increase, this is the the extra bit, the increase in weight must be proportional to the increase in area, because you get way heavier with slightly bigger feet, and that would change the pressure. So increase giving the same pressure as like the child, maybe I should put as the child, leading to sinking the same depth. Right, both the adult's and the child's footprints are the same depth. Calculate the mass of the child. So this is the pressure of the adult is equal to the force of the adult divided by the mass of the adult. And both pressures are the same, so they both equal the force of the child divided by the mass of the child. I'm just putting a little c so you can sort of hold on thing, which is equal to the pressure of the child. Cool. Right, I know what the force of the adult is, and I know what the mass of the adult is. What am I talking about? Not mass, it's area. And that is area as well. So force over area. Right, now, what will I do? I'll rearrange. I'll rearrange. So we're going to try and find the force of the child. So the force on the child this one here, will be equal to, so the force on the child is equal to the force on the adult divided by the area of the adult. And if you times both sides by the area of the child, it moves up onto that side. So times the area of the child. You could have just made this a number and then times both sides by the area of the child and it'll move it up. And that is equal to, we'll find out what that number is. So I'll just put the numbers in, equals 517.5 newtons. So it is the weight force of the child, 517.5 newtons. 1 foot is 0.015, so 2 feet must be double that. That's where I've got this 0.34 for the area of the child. And now, on your formula sheet, you have force is equal to mass times acceleration. In other words, mass is equal to the force of the child divided by the acceleration, and that is going to be due to gravity because that's what's pulling him down. So you're just going to get 517.5 newtons divided by 10, because in year 11 they just use 10 as gravity, and that equals 51.75 kilograms, which sounds about right for a kid. Right. The adult's weight force does 21 joules of work on the sand. Calculate the distance adult's feet sink into the sand. So work is equal to force times distance. It's in your formula sheet. And work is energy. Energy, work, energy. I mean, work is just the energy transfer. So you can just think of it as energy in this case. So we're trying to find the distance. In other words, distance is equal to work divided by force, because we're going to move that under force. And what is the force? So the force is the weight force. So that is just going to be equal to 21 divided by the weight force, which is 690 newtons, which is equal to 0.03 meters. And I'll leave the other stuff out because that is fine. Maybe not. 304. And then when you do this here down the bottom, you go, always put your answer down the bottom here. I should have actually put this down here as well. So mass is equal to 51.75 kilograms. This just makes it easier for your markers. And distance is equal to 0.0304 meters. Right, and there's no worry about significant figures or anything like that there, because it's just never come up in the last 10 years, and it's not part of the standard outline, so you don't have to worry about it.